Now it's all set to go for the protein synthesis. The actual protein synthesis is happening in the elongation phase. This is the most crucial and mechanized stage of translation. Here you can see the addition of amino acids one by one to form the polypeptide chain. So in short, at the beginning there will be a recruitment of the second amino acyl tRNA corresponding to the second codon in the mRNA, followed by a peptide bond formation. This peptide bond formation occurs between the first and the second amino acids. And as a result of the peptide bond formation, the bond which is holding the amino acid, the first amino acid to the first tRNA will be lost. And as a result, both the amino acids will now reside on the second tRNA. And this deacylated tRNA at the P site will be shifted to the E site. That mechanism is called translocation. And this process will continue until a stop codon enter the A site of the ribosome. Then that comes with a termination event. Okay. So as we seen in initiation, here also certain external proteins are supporting the mechanism. They are called as the elongation factors. There are three factors. Significant factors are EFTU, EFTS and EFG, seen in prokaryotic system. Again, these are G proteins with GTPase activity, and EFTU can actually this EFTU usually exists as bound to GTP, and which can complex with the next amino acylated tRNA. That means this is the counterpart or the doing the similar function as done by the IF2. IF2 was recruiting the first amino acyl tRNA to the P site, and here EFTU will do the same function. That means the second and the next onwards amino acids will be recruited into the A site, and never this EFTU, remember that EFTU cannot recruit an amino acyl tRNA to the P site. It can do this only to the A site. Okay, so only IF2 is responsible for recruiting amino acyl tRNAs to the P site. That is very unique to IF2. Clear? Then the second factor is EFTS. This is usually helping the EFTU GTP regeneration. Then EFG is involved in the translocation process. Clear? And elongation also we'll discuss in three phases. First one is the binding of the incoming amino acyl tRNA into the A site of the ribosome with consumption of GTP, and also there is EFTU involved, and there is also a recycling process with the help of EFTS. Then the peptide bond formation with the help of an enzyme called peptidyl transferase. There is a peptide bond formation between the two amino acids. Then the third one is the translocation. This is the movement of the ribosome along the mRNA. As a result, the dipeptidyl tRNA at the A site will be shifted to the P site. Clear? So along with that, one more thing will be happening. The deacylated tRNA which was at the P site might have shifted to the E site, and this process is called translocation. This again consumes GTP. And finally, the deacylated tRNA from the E site will be dissociated out of the complex by the next round of translocation. So let's see the first step of elongation. So you can see the image. in which you can see there is the second amino acid which is bound onto the tRNA, second tRNA, then complex with the EFTU GTP to form the complex, and that will be attaching into the A site. And there is a regeneration of EFTU GTP with the help of EFTS GDP complex. That means EFTU GDP will be released. EFTU GDP will be released once the GTP is hydrolyzed after the successful transfer of the second amino acid tRNA to the A site. And this EFTU GDP will be attached by EFTS complex, and this EFTS has higher affinity to GDP, so that the GDP will be bound onto the EFTS. Then there will be complex formation of EFTU-TS. Then this GDP will be phosphorylated to form GTP, but this GTP has higher affinity towards EFTU. Then this GTP will be transferred to EFTU to form the EFTU GTP. Then this EFTU GTP will be recycled for the third amino acid tRNA to recruit into the A site further. Clear? So that is the first step in which the second amino acid tRNA will be recruited into the A site. Then the second step of elongation is the peptide bond formation. So the peptide bond formation occurs between the amino acids. Actually, the alpha amino group of the amino acid in the A site, which is the second amino acid, right? Amino acid in the A site means the second amino acid, which act as a nucleophile. That means the amino group of the second amino acid act as a nucleophile, and which will attack the carbonyl carbon atom of the first amino acid in the P site. You can see the image where the free electrons of the amino group is attacking the carbonyl atom, and this is helping to shift the bonding patterns. And this nucleophilic reaction displaces the amino acid from the first tRNA to the second tRNA and produces a dipeptidyl tRNA in the A site. And now the uncharged tRNA F met remains bound to the P site. This is the second step of elongation. And this reaction is usually catalyzed by the enzyme peptidyl transferase. And it was previously it was thought that it will be definitely it also will be a protein, but later on it was clear that it is not a protein, but rather it's a RNA molecule. So the researchers have found that this is the 23S rRNA of the 50S ribosomal subunit, which act as the peptidyl transferase. So this is an evident example of a ribozyme, that means an RNA acting as an enzyme. And this inherent activity is one of the unique feature of translation. Right. So the ribosomal RNAs are very crucial in translation. The first one was the 16S rRNA, which is found in the 30S subunit, helping in the attachment of the mRNA precisely to the P site to locate the AUG. The second rRNA, 23S rRNA, is again a much more important reaction. That means the peptide bond formation is catalyzed. Clear? Now the third step of elongation, the translocation. So now the picture will be like there is a dipeptidyl tRNA at the P site and there is a deacylated tRNA at the E site, and the A site will be vacant. Clear? And now the third tRNA will come to this place, and when the third tRNA comes, there will be the second peptide bond formation, and the third tRNA usually comes with the third tRNA occupies the A site and causes the peptide bond formation. then that will also will be followed by translocation. And what is actually this translocation means? Translocation is actually the movement of the ribosome by a distance of one codon toward the 3' end of the mRNA. Right. So the ribosome will move, or it's otherwise also you can also imagine that the mRNA is moving. So either mRNA or the ribosome will be static. Okay. So the process require energy by the GTP hydrolysis. Then EFG is also involved in the translocation event. This EFG is a GTPase protein that can hydrolyze the bound GTP. Then the tRNAs in the P and A sites will be shifted to the E and P sites respectively. And the A site will be free to accept the next tRNA. And in the next round of translocation, the tRNA which is bound to the E site will be excised out of the complex. Okay. This is because how the movement occurs, how the movement of ribosome causes shifting of tRNA from P site to E site or from A site to P site. This is because the mRNA is bound to the tRNAs tightly through the codon-anticodon interaction. That already we know that there is a codon-anticodon interaction and they are moving through a channel. And as the ribosome moves, the bond between the mRNA and tRNA still exists, and so they move together. But when the third tRNA or the fourth tRNA comes to place, the tRNA at the E site has to dissociate. This happens because the E site of the ribosome is mostly occupied in the large subunit, whereas the mRNA is seen, or mRNA is usually entering in the 30th subunit. There is a small channel, there is a small orifice through which the mRNA is moving within the 30th subunit. So when the tRNA is pushed from the A site by the incoming amino acyl tRNA, the tRNA has to move in the opposite direction. But during the movement, the bond between the tRNA's anticodon and the mRNA's codon will be cut, will be lost, and that causes release of deacylated tRNA from the E site to excise out of the complex. Okay, so this is what we see in the elongation phase. So this will continue until a stop codon encounters in the A site.